This is the chapter 10 worksheet 2. Last time we learned about the concept of reduced bearing and the true bearing. So you have a basic concept about this one. So let's go through the question number 1. And the data is shown in the graph. And the first question asking us to find bearing of L from B. So if the question asking us the bearing from B, you need to put a cross on B. And the L is here, so our target is how to find this one angle, let's say B, okay? So first of all, if I want to find B, so we will have two parallel lines, okay? So this one I find, let's say A, okay? So A is equal to B because of the alternate angles. So that means how can I find A is easy because the first bearing is 210 and then you can minus 180 degrees. So you can find A, okay, this first part. And for second part is by alternate angles. So that means if B is 30 degrees. Okay, so the last time, so the bearing is 30 degrees. And as when we need to give a compressed bearing or true bearing is according to the question, okay? If the question gives us is a true bearing, then our answer will give a true bearing. And if the question is compressed bearing, then I can give the answer in compressed bearing, okay? So for part B, let's move to the part B. Find the distance between B and L, okay? So for B and L, so that means this angle. So for the first part, I need to find the length here, consider the triangle BLP. So the first part is 50, so if I can find this angle, then I can have a pair of angles and the length. So for X is easy because it's 180 minus 50 degrees. And then, so the whole angle will be 50. L for angle BLP will becomes 50 plus 30 degrees, which is equal to 80 degrees, okay? If it's the first part. And for the second part is the Z. Okay, second part Z is 180 degrees minus 240 degrees minus 180 is equal to 60. It's easy. And the third one, okay, how can I find this angle? Okay, because this is our components to find BL. As we learned before, we have a parallel line here, okay? So let's say, oops, this one, Y plus Z, oh sorry, not here, it's here. Okay, this, we can have a alternate angles because 130 degrees is equal to Y plus Z. So that means this is the third part I can find the angle Y. So once we can get a pair of angles and length, we can find our target. So therefore, we can have a side formula. So we finish the part for BL. Okay. So for question number C, so the question number C is when both move the pier from B to P. Okay, so both from B move to the P. Okay, so what is the shortest distance between the boat B and the lighthouse L? So it should be the shortest distance from L to line BP. Okay, so I can write down for you shortest distance from L to BP. So that means it's LD. This is perpendicular distance. So first of all, I need to find, because we know LB is 47.7, and this one is 50, and this one is 70 degrees, and this one is 80. So how can I find LD is, first of all, we need to find this angle LBD. Okay, and then I can apply the sine function because of the right angle triangle. So LBD, and this one is 30 degrees and 47.7. Okay, remember to use all the digits in the intermediate values, so we can find the answer of 23.9. Okay, that's the end of question number 1. And then let's move to question number 2. So for question number 2, for a part, there are some details is 77 degrees and 202 degrees. And then there are two lengths here. The part A is find the distance between Q and R. So this one is our target. So according to our question, we consider this triangle, and we have a side and these two sides, and the angle between them, we know it because it's 202 minus 77 degrees. So our first part is to find the angles of our PQ, and the second part is because of SAS format, then we can apply the sine formula and to find RQ easily. Okay, so this is the second part. So let's move to the question number 2b. Find the bearing of Q from R. So we need to write down a cross again from of Q to R. So let's say this angle, right? So I erase the purple color. So our target is how to find the angle of this one. Okay, it consists of two angles. So one of it is, let's say A, and the other one is QRP. So let's find it. So for the first part is because last time we found this angle theta is 202 minus 180 degrees. So this first part. And for the second part is by alternate angles, A should be equal to the theta. So second part. Okay. And we have finished the first component. For the second component, how can I find angle QRP? Okay, so last time we know that QR is 34 meters, and we know three sides of it. I draw it for you. One is 14, one is 24, and one is 34. So I can find the angle of PRQ. So it's SSS format. By then you can apply the cosine formula. So once we know the angle of PRQ, then we add together, then you can get the answer. And remember, don't forget we need to apply 3 digits. Okay, so we need to put a 0 before the digit 4. So we finished part B, and last one is find the area of triangle formed by PQR. Okay, so it's easy because I try to draw a figures for you. So one is 14, 24, 34. You can apply it by many methods. One is by you can use the sine formula, 2 times 1 over 2 times A times B times theta, or you can use the Heron's formula. Okay, both of it are okay, so it's easy to get answer of question number 2C. And then let's move to question number 3. So this question is a little bit long. So according to the detail in the question, which shown in the graph, okay? So the first part, find the distance between P and Q. So that means this distance PQ. So first of all, let's say whether we can apply the cosine formula or sine formula. So first part, let's say this one, if I can find this angle, okay, then we can apply the sine formula. Okay, so first of all, I split it into 2 parts of the angle. The first part is A, and the second part is B. So for the first part, A is equal to 55 degrees because of the alternate angles. Okay, and then for the second part is B. Okay, so it's 180 minus 143 is easy. So and then the third part is PQR. Okay, so it's add up together. So we can find the angle, a pair of angle and a straight line. So this add together is equal to 92 degrees. So therefore, we have 126. Oops, sorry. So we can find the angle of QPR. Okay, so it's the third part. Find QPR by sine formula. So last time, once you finish the QPR, you can find the answer of angle R by angle sum of triangle. It's the fourth part by angle sum of triangle. So once you can get this angle R, then you can apply the sine formula again to find PQ. So this is the fifth part. Okay, so therefore we can finish the part A. And for part B, find the bearing of P from R. Okay, so find the bearing of P from R. So first of all, you need to write a cross from R here. So I erase the rough work on question part A. So find the bearing of P from R. So of P from R. So our target is how can I find this angle C? Okay, it's not difficult because according to a parallel lines, so it must be 55 degrees plus angle P here, right? So therefore, angle C is the first part. Okay, and then our bearing is from 0.00, that means 180 degrees plus C. So this is the second part. Then you can get the answer of the bearing. And the last part is a radar located at Q. So a radar here, detect any ship within 80 kilometers. So that means if any ship which is near 80 meters, okay, so let's say we can write a circle if it's 80 kilometers, sorry, then it will detect the ship. So let's say if a ship sails from P to R, that means we have a ship from P to R. So can the radar Q at Q detect the ship? So that means is it the shortest distance from Q to the boat is longer or shorter than 80 kilometers? Okay, so that in this question, let's try to find the value of QS, which is the shortest distance from Q to PR. Okay, so in triangle, I try to draw a triangle for you. So in the previous part, we can find this is 126 of QR and S, and the angle is 43 point something to 93 degrees. So you can apply the sine function to find QS directly. And once you can get the answer is QS is 86.4, then you need to write it down is greater than 80 kilometers, so it cannot be detected. Okay, so we finished part C, and let's move to the last question, question number 4. In question number 4, so the first part, find the distance between A and C. So that means this values. So we can apply, first of all, you need to find the degrees of this angle to apply the sine formula. So it's not difficult because we can apply alternate angles to get the angle number 1. And then because we have a value of 18 meters, so you need to find the opposite angles from this side 18. So it's our second part. Okay, but how can I find the second part? You need to find this one first. Okay, and then you can apply the angle sum of triangle to find the angle C. So for the presentation, this first part is angle ABC, our angle 1. Okay, and then for angle 2, it's angles on straight line. This one is authentic angles, and this one is angles on straight line. And the third part is angle sum of triangle. So we finished the first 3 parts, and we can apply the sine formula to find AC. Okay. So for part B, find the area of garden ABC. So let's move to the second part. Okay, I try to draw a figure for you. So last time we find AC, right? And this one is 18, AC is 14.8 something. And then this angle is 50 degrees. So we can apply the formula of sine formula. Then you can get the answer of the area. So remember, use more digits in the intermediate values. Okay, last time for the part C, a straight line path from B to AC. So that means you need to build a road from B here to AC here. Okay, so can the length of the path is shorter than 13.5? That means we need to find the shortest distance from B to AC. Okay, shortest distance from B to AC. So if the length is shorter than 13.5, then you say yes. Otherwise, you say no. So that means it's for part C. Okay. So just write the perpendicular distance and then consider the triangle of ADB. Okay. So it's right angle triangle, and this 18 and this is 50 degrees. So you can apply the side function easily. And you can have other method because we find the area of ABC. Area is 102. Okay, so and this shortest distance is, we can call it the height or altitude. Okay, from B to AC with the base AC. Okay, if the base is AC, the altitude is BD, and which is the shortest distance. Okay, with base AC and altitude BD, then you can find the height of DB also. Okay, so that's the end.